Yo, what's up? This devlog is coming a little late because I've been very lazy the past few days, and finishing this devlog means I have to start working on my game again. So without wasting any time, let's get right into the list. Actually, let's waste a little time. Please like and subscribe because literally everyone that watched the last video was not subscribed. Okay, thanks. So the main focus this time around was getting some sort of foundation for my fight system. But before that, I needed to actually input the potato chase system because I said I did it last devlog, but I completely lied about it. And if you actually go back into the last video, you can see that I get kind of close to the potato and it doesn't chase me. So you can catch me in my lie, but I actually did get it in. You should be able to see it right now. Pretty much there's a minimal radius for the potato, and if you are inside that radius, the potato notices you, turns red so the player knows that the potato's in like chase mode, and then starts chasing wherever you are. Another thing that this clip shows is if the player leaves the chase radius, the potato goes back to its spawn point, but it doesn't have to go all the way back to its spawn point. If there's a certain range, or if it's close enough to its spawn point and the player's in range, it just starts chasing the player again. There's also another variable called the fuck it variable, and I can show it on screen right now. And pretty much this allows the potato to chase the player no matter how far it is away from its spawn point, but this is only if the player is like really close. And I needed to implement this in because there's points where it feels like the potato should be chasing you, but because it was so far from its spawn point, it just didn't chase you anyway. So that fuck it threshold is there to make it seem like the potato is reasonably chasing you if it's close enough. Also, some cool tidbits about this chase system is that it taught me about the pathfinding AI that Godot comes with, and I pretty much did this to make sure that potatoes cannot get stuck on objects like chests in this example. So using the tile set, the potatoes know what blocks they cannot walk through. So in any case that there's like an obstacle in the way, the potato knows to just go around it. And in order to save some processing power, this sort of around the way pathfinding only triggers when the potato hits the wall. So if the potato is freely moving and there's no collisions, it's just going a beeline for the player. But if it does detect some sort of collision, it's gonna look for a way around it. Now in the actual battle sequence, I've added a basic bar animation that leads or that transitions the main game to the battle part of the game. And it just changes the world into a different scene in Godot that is supposed to be the battle sequence. It's just grass surrounded by trees and then some stone that shows where the players will be spawning. And then to actually spawn the characters, I have nodes that are friendlies and enemies that are put into groups. And I use these groups to figure out if all the enemies are gone or if all the friendlies are gone, which is like the beginning of my win-loss state. I spawn children, which will be the player or enemies or teammates on these nodes so that they will always be in the correct position. And I can like numerically add them. So it's a lot easier to add and remove and then also count them. So once the animation plays after the collision, a signal is given, which pretty much creates the enemy party using some random numbers for now. And then it initializes the battle info. And then in the battle info, that enemy dictionary is put into the enemy party variable, and that whole thing is then switched into the final battle scene. Now, in the battle scene, what happens is the enemy party is filled with everything that was in the enemy party in the battle info script. And then you could see I use a match to make the types. So right now the only enemy I have in the game is the balance type. But once the thing is put inside of the enemy party, you actually go out into the battle scene, and at the certain enemy nodes, it's placed in numerical order. So that's the whole process of how the world is filled. And it's the same thing with like the player and the player's party. And now we're at the part that I was dreading the most, which was the UI. I've never worked with the UI system before, so here is me trying to figure out a way to create a nice looking battle order system. Of course this is all prototype, but I just wanted to get it to look like it was expanding with the team size, meaning it was not all one size, it was dynamic and it depended on how many characters were in the fight. And then I just needed it to sort after that. So here's me just playing around with some ideas and figuring out how I wanted the layout to be. And after that, I was programming it and so that the game could figure out who was the fastest in the entire game, and then from that, figure out how to place them in the bar in the correct speed order. I also included a indicator that shows who the current active enemy or player is, and then also you will see like the prototype sprite for the main player character, which I'm still working on. Like I said, I've been a little lazy this month, but I do have some sort of prototype for his sprite, and this prototype is actually what I'm going to be modeling the rest of the characters off of. But yeah, so that is the battle order. Next up is the actual attack UI. Pretty much right now the bag button doesn't do anything, but the attack button, what it does is that it shows you all the attacks that the player has enabled. And on button press, it allows you to select a target. And the way that I have that is by making a separate sprite, pretty much with just a white outline. You select a target, and with that target, the attack and its effects are put on the target. And then that whole thing loops. I'm going to explain the process a little bit more because I am pretty proud of how the process is. But for now, this is just the UI. So you can see me like Googling and trying to figure out how to get these grids to work, what sizes I like, what was taking up too much space, what wasn't taking enough space, what seemed clean, what didn't seem clean. And pretty much after this section, I needed to make sure that the clicking was responsive and that it looked good. Here you can see me testing it out in game. You can also see that the battle order on top is now working how I needed it to be. You can see that right there, the select target is working kind of. At this point, the reason why it wasn't working is because the select target wasn't restarting the game loop. Which I obviously needed to be doing. The bug that I was running into is that after I select a target, it was letting me attack that target again and again and again and again, which is not how turn-based works. But you can also see that the text, how the text is being updated is that each player has a dictionary attached to it that pulls information from a JSON file. And in those JSON files, you'll see not only the move's name, but also a move string, which the game uses a match to figure out what it needs to do. Right now, the only type I have is just a basic standard attack. So when the match is triggered, the only thing it could match with is attack. And what that attack does is it just minuses the current health of whoever. Oh, you can see the bug right there, but it just subtracts the attack damage stat from the current health minus some damage defense percentage. But yeah, so it updates its button name by using the attack name that's in the dictionary, and nothing happens until the click, like actually clicking the button happens. So once you click the button, the attack stat is generated. Once you select the target, the attack stat is applied, and after I fix the bug in the video, pretty much the game loops, and then we actually have a turn-based. Now, to explain the actual attack sequence, what happens is battle process is what I'm using to separately handle the actual process. So you can see that after the battle process is initializes, it runs start turn. Now, inside of start turn, you get who the character currently is, and what position they are in the character list of the speed, so I can update the battle order. And in this, pretty much I'm just waiting for an attack to be selected. Now when the attack is selected, I figure out what is happening to the damage stat. You can see the match sequence up there, and all it is attack. If it's friendly, what it's waiting for now is on character target. And this triggers when you actually select an enemy. After you select an enemy, it takes who that enemy is and then applies the damage to the actual person. Now, what needs to happen is that it needs to reset. So after the turn is ended, it pretty much starts the turn again, but increasing the index of whose turn it is. And I decided to do it this way instead of a process statement because I thought that this would reduce processing power. Because if I'm doing it on an increment basis instead of a every tick basis, I don't have to have the game looking for every single input, every single tick. I can just let it go step by step, and that way reserve a little bit of processing power. And now to explain what happens if it's an enemy's turn, pretty much if it's an enemy's turn, there is a timer set. And that's the only difference from the friendly's turn. That timer is there because I think in this example, you could see that if it wasn't there, the damage would just be applied immediately. So you wouldn't know that the enemy went. And obviously it's a computer, so the calculations are happening immediately. But that timer is there just to make it feel like the enemy is like quote unquote thinking or like doing an attack. That will be more obvious when animations happen, but for now it's just a timer. So I wanted to go over what happens inside of the battle version of each character. When a character is spawned, their number processor, and in this case it's the balanced potato, their number processor is called, and this gets the health, attack, defense, and speed stats from the game info dictionary. In an enemy's case, it's always going to start in max health, but in a player or the player's teammate's case, there's going to be a current health in order to have the continuity there. But in this case, it's always going to start at max health. So after the numbers are processed, what happens is certain recursion happens because of how the leveling system works. So there's no current way to level up yet, but there are level stats implemented. So let's say a character is level 5. The way that the stats work, if you've seen my spreadsheet from the last video, is that there are set formulas that happen to each stat based on each level. So it's always going to start at level 1, but if I'm fighting a level 5 enemy, what needs to happen is that those formulas need to apply to the current stats and level them up. And the reason why I decided to do it this way is because I didn't want to write down each individual value inside of the file, because I felt like that was going to take a lot of time and a lot of going back and forth between the code, or at least the dictionary file, and then my Google spreadsheet. So I'm doing it this way instead, just so I can always start at level 1 and then inside just give it like level 5, and then it will level itself up on its own. So after I fill in the dictionary, this dictionary becomes referenceable within the battle process, so it's easier for me to grab it if I need to. And then the reason why I decided to show you the balanced potato is so you can see what happens on the enemy AI side. So when it's the enemy's turn, instead of us obviously picking the move, because when it's a friendly, we're picking the move and the game is waiting for a button press. Because we're not pressing the buttons, we have to artificially press the button. So function pick move is called. As of right now, what happens is that based on your level is what determines what current moves you can use. And in this AI's case, there's only 2 implemented moves at the moment that they do the exact same thing, but I just needed them to pretty much demonstrate how percentages work. So you get a random number from the random number generator, and based on what I feel like the enemy should be prioritizing, in this case it would be bonk, this if statement pretty much says 70% of the time pick bonk and 30% of the time pick mash. What's cool about this is if I'm doing boss battles, let's say like actual characters and not potatoes, I can make this random number generator a little bit more complex. So instead of saying 20% this move, 60% this move, and then the other percentage this move, I could say if the player character is less than this certain health, use this specific move. Else, then I can use the percentage random movement. So that's my way of making the character enemies smarter than the potato enemies, because the potato enemies are purely RNG with like a weighted RNG, I guess I should say, because of the percentages, while the characters can have certain if statements and conditions that determine their moves, and then as a backup use their weighted randoms. It picks the name, which is in this case, let's use bonk, right? And so it goes into the move list, and since the move list is like a list of 0 through 3, I just find which button has the name bonk. once I do that, I just literally call the same function that is called when you press the button. And that's my way of artificially pressing the button. And because I'm pressing the button, the next part of the process is called. And now the only thing that it's looking for is a character selection. So this is what pressing the button did, this whole thing. Now we're on character target. And obviously we can't pick ourselves. The enemy has to pick it for us. So pretty much what happens here is inside of the button being pressed, if it's an enemy, what needs to happen is that it picks pretty much a random number as of right now. And again, I could do the same thing with character enemies, meaning I can make the character enemies conditionally pick certain players instead of having it up to a random enemy. So, but in this case, it's the potato, so it's just going to be completely random. And the way that it does that is it has the timer. So if it's an enemy, pretty much start the timer. This is the thinking process. In the timer timeout, it randomly selects a random player, teammate, whatever, and it artificially clicks them. And then we can move on into the on character target. And then after that, same thing, it moves on to end turn, checks to see if there is a win or a loss, and then it restarts. And so I'm using this to pretty much demonstrate that the players and enemies do the exact same thing. They both go through the exact same steps, but on the enemy's case, it artificially chooses a button and then artificially clicks a target. And the only reason why it looks as good as it does is because I can hide the UI. So technically the UI is still being updated for the enemy. I'm just hiding it so you can't click it, you can't see it, and it pretty much feels like it's the enemy's turn. And that pretty much does it for this devlog. So I actually have a playable version of the game where I can run from potatoes, fight potatoes, get destroyed if I have more than one enemy potato, which is great. Being destroyed by a team of potatoes also gives me an incentive to add Sky, the first and actually main teammate of this game. So in the next devlog, be on the lookout for Sky, be on the lookout for the first map, and pretty much polishing the first level of the game that I should be posting out so people can actually play, and I'll have some sort of feedback. Also, I shouldn't be having any more ridiculously long explainy moments like I just did right now, because the basics of the combat system are going to stay the same. The only thing that's going to change from here on out is adding more moves, changing a bit of the matches for different types of moves, like the status effects move or like the multiple moves, but from here on out should be the same. The only thing that's going to be different and have another long explainy segment will be when I add the QuickTime events that's supposed to differentiate my game from other games, but until then, shouldn't be anything really long and drawn out. So thank you for sticking around for that. Thank you for following the progress of this game, and I hope to see you in the next devlog. Peace.